Hello, it's your friend Doublebyte, and we're going to try something out. So, as my, profile says, I'm bipolar, bisexual, and a computer programmer. Clearly, I like video games. I complain about being bipolar, whenever it acts up. And I kind of, offhand talk about my sexuality. And I'm a little more vocal about queer stuff on Twitter, which you should follow me on, by the way. But I don't really talk about my programmerness that much. And I've noticed I have quite a few followers on Twitter that are in the field of programming, and it's something really important to me, but I wasn't sure how I could talk about programming in an interesting way on this channel. So I don't know if this will be an interesting way, but I'm going to give it a shot. So I've been doing a lot of these little code prompts on this website called Exorcism, which has a ton of different programming languages, and it's really easy to use and really fun. And I figured I'll go through. I have picked out 2 exercises that are the next 2 on my list, and I thought I'd code. For people who are starting out with programming, this is not a tutorial. But it might help you think like a programmer, see what kind of the thought processes are. For people getting into code, getting into programming who are a little more advanced, maybe you'll find it interesting to see someone else work through a problem. Think about it. I just thought this would be a fun little exercise. We'll see how it goes. So here's the website Exorcism. I have open the bracket push exercise. This has the test suite and the README. I've already pulled it into my repository, so let's check this out. Hold on. Gonna make that invisible again for 1 second. There we go. Okay. So we're in our bracket push folder. We've got a README, bracket push.py, and our tests. We can just check out the README. Pretty straightforward, pretty easy. And let's give a look at our tests. Exorcism has very specific kind of organization to their tests. So you do need to dev to the test rather than dev to what you necessarily think the answer should be. Sometimes I find this annoying, but usually it works out pretty well. Okay. So basically we have a function, check brackets, we pass it a string, it asserts whether it's true or not. And there we go, just simple old bracket matching. Not too bad. So looking at this problem, first of all, looking at this problem, when I see it, I think to myself, how can we do this? It's a known fact that you cannot match arbitrary brackets with regular expressions. I really hope that's true. I'm 99% sure I remember that from my theory of computation. But anyway, we can't do that. And we want to do this as efficiently as possible. So as soon as I think of this, I think the following steps. Make a stack to store tokens. I'll call them characters. Track the count of what the previous symbol was. So what the previous kind of closing symbol was using this stack. So what's the better way to phrase that? Make a stack to store the characters. Better phrasing. Okay. Again, freeform thinking out loud. We're going to make the stack, and it's going to store opening and closing characters. Now, let's think. Do we need it to store closing characters? The answer is no. Let's say we have square bracket, curly, all open. If the next bracket is anything but a curly bracket, that should throw an error. So therefore, we don't need to store the closing ones, only the opening ones. What should we call them? Opening. Then or when we pass this a closing character, we'll see if it matches the last open one. And finally, we need to make sure everything does get closed off. So after we're done parsing the string, if there's anything left in our stack, return false. Cool. This sounds about right to me. I'm going to try to code with as minimal Googling as possible. Googling is the heartblood of all programming, but watching me Google stuff is not interesting. Watching me code is probably not interesting, but it's try to be optimistic here. Anyway, so we'll just make ourselves an empty list for I'll try to talk then type. This way the keyboard's really loud, and post-processing and cut out the keyboard. Okay, so we're going to look at each character of the string. And let's define our character sets. So since these are sets, it may be more efficient to store these in a Python set, but for now we'll just put them in these nice lists. Keep things as low complexity as possible. So we're going to iterate over our string. For character in my string, if the character is an opening, we're going to push it onto the stack. And by push, I mean append. Python may have a more optimized stack data structure, but we're just going to use a basic list. I want this to be parsable by people who have very little programming knowledge, but I may use some terminology and not explain them, so I apologize for that. Stack is first in, first out. You have a stack of dishes, you put a dish on top, you can only access that top dish until you take a dish off. Now you can access the second dish. That's stack 101. So if you have an opening, now, and we're going to be inefficient. Let's make this as explicit as possible. So we're going to make a dictionary. And for the values, we're going to say if we pass this a closing bracket, here's what we expect. So if we passed it a closing curly brace, this should match an open curly brace. If we pass a closed square bracket, we expect an open square bracket to be there. If we pass it a closing parenthesis, we expect it to find an open one. So if our character is an opening, we append it to the stack. If it's a closing, let's see. Match is going to be wherever our mapping goes to there. Sorry. Going to check our character and get what should be its pairing character. And we're going to see if the last item, the top item of our stack, is equal to the match. So if match is not equal to the last item in our stack, return false. We have a mismatch, so we know we got to stop. But there's another condition here. If we have more closings than we do openings, this will cause an error because we'll be trying to access the last spot of an empty list. So if our list is empty, or if the last item is not a match, return false. What's the name for this? Python is a programming language where it checks the first condition and then the second condition. If we put these two conditions in the opposite order, I believe this would throw an error. So, when we find a close, if it doesn't match our opening, return false. Otherwise, we're going to pop the last entry off of our stack. And I believe that's valid Python syntax. But we can try this out. We're going to, in our console, let's open up Python in interactive mode. We'll make a fake stack here. Try to pop -1. That gives us 3. And now if we print my stack, you only have 1, 2. So pop -1 returns the top thing, or in our stack, the last thing in our list. And please ask me questions in the comments if there's anything you have questions about. Again, I'm trying to not do so much teaching as just kind of doing by example and hopefully being relatively clear. So when we're done with our string, we need our last condition, which is if we haven't popped off all of our opening brackets, okay, so let's look at the whole picture. We want to make a stack to store the openings. We make a check when it's past a closing. And if it's not empty when we're done, return false. So we find an opening, add it. If we find a closing, figure out what its match is supposed to be. If we've run out of characters to match, or if it doesn't match, we'll return false. Otherwise, we've had a match, we pop from our stack. And if we're done and we haven't popped everything, that's no good. So now let's see if we wrote this correctly. We'll run the test they gave us. Well shit. We did it first try. Yay, okay, nice. So yeah, that was a pretty simple one. I thought that happened to be the next one on my list anyway, I believe. But I thought that'd be a good example regardless. Now let's look at the other one, which is going to be a bit more complicated. Can you see what I'm doing right now? Oh, nice, you can't. I don't think I'll have to review the footage. Anyway, so this assignment, and let me pull up this again, is to add the numbers to a Minesweeper board. So take this board of mines and transform it into this. So I, not to brag, have written all of Minesweeper. Like I've written an interactive Minesweeper game in an online program called REPL, which I'll probably go over my code for that in a later video. So that has full interaction, user input and stuff, and it's admittedly a bit messy. So, but this still seems like a cool exercise. So we're going to do it. Let's go here. Let me... Actually, this should be fun. Let's check out our tests. Okay, so we are importing what looks like an array. Nice. I was hoping we wouldn't have to parse that string. And we just check what's around. Looks good. So, what I'm seeing here is something cheeky we can do. So, we are given that border, and that's a huge hand because it lets us take a few shortcuts. And I am fond of taking shortcuts. I'll show you what I mean in a second. So, oh, and let's actually, I just want to see one thing quick. So we pass it the input, we get this output, and there we go. So, let's diagram this out like we did last time. Given array of rows, output given array of rows, output an array of rows with mine counts. So step one is, so what I'm proposing is we're going to do this very simply. We're going to iterate through our rows and run and do something when we hit a mine. So iterate through our rows, and when we hit a mine, we'll get the neighbors. What do I mean by neighbors? I mean the spaces above, below, left, right, and the diagonals. So this is why having the border is a huge help. If we didn't have the border, we would need to do special cases. A mine on the top row wouldn't have a northern neighbor. However, it will always have a northern neighbor, a southern neighbor, etc., because we have this grid structure. So that's very nice. And again, that will make a little more sense in a little bit. So we're going to get the neighbors. If the neighbor's blank, which means we haven't checked that square yet, if the neighbor's not blank, which means it was set by a previous mine, we're going to increment it. And there we go. So we have our array of rows. So we're going to iterate for start board. Now pause. In order to get the neighbors, we're going to want the indices of where they are. So when we get a mine at row 1, column 1, we want to look at row 1, column 0, row 1, column 2, etc. So that means when we do iterate like we're doing in Python, we are going to be getting the actual rows and then the actual characters in those rows. We don't want that right now. So, oops. So my work computer has a shortcut where if you hit Control and then arrow key, left gives you home, right gives you end, and it's the greatest thing on the planet. My home keyboard does not do that yet. There we go. So now we're iterating over the indices. So if it's 5 by 5, the first, if it's 5 rows, 6 columns, we'll go through 1 through 5, or 0 through 4, and then 0 through 5. So the character at the position is going to be first we get the row, then we get the column. Really hope that's true. I believe it is. So now we need to check what this is. If it's anything but a mine, we don't care about it. So if we found a mine, we're going to get its neighbors and increment the numbers. So let's get its neighbors as a separate function. We're going to make a list of points. Yeah, make a list of points. So, what's the best way to do this? So, we're going to say, actually, yeah. And then, so we have identified our row and our column. Yeah, let's just call them this. Our row and our column for our point. And we're going to have a list of neighbors. Let's just brute force this. So we're going to want to put in tuples because that will make things easiest. So first we want the upper left diagonal. So it's row -1, column -1. Again, because we're going one space up, one space to the left. We're going to have 8 neighbors. Okay. So that's the upper left. Next, we want upper middle, which is going to be the same column and one row up. next, upper right, same, so up one row plus one column. Next we want directly right, or directly left, which is same row, next column over, directly right, same row plus one column, and then we got lower left, lower middle, and lower right. And these are all going to be our row plus ones. Oops, I have no idea how I did that. Yeah, I just made things bigger somehow, I don't know. Weird, okay. So, middle is same column, right is column plus one. And then return the neighbors. So yeah, so to review, we're getting the 8 squares surrounding our mine. And in this case, because we have that border, we know that all of them are going to be valid points. It's kind of a dangerous assumption, but it's within the parameters of this exercise. So if the character is a mine, our neighbors, we're going to pass this to the tuple of our row and our column. Then for each of these neighbors, we're going to check them out. So for n in neighbors means we're taking each object, each item of neighbors. This is not using the indices. So let's make this a little more explicit. For n in neighbors, our row is the first value, our column is the second value, and the character at that point is that one. Now, what did we decide to do above? Where are we? If the neighbor is blank, set it to 1. If it's a number, increment it. So, if it's blank, we'll set it to 1. Else if, now there's a Python function called isDigit that determines if a string is actually a number. So we're going to leverage that here. And that's built in the standard Python library. So that's true the number if the string is a number, false if it's not. So if it's a number, I'm going to change that value to the string of the integer. Okay, backing up. The number is the integer version of new character. So if new character was equal to string 1, this will give us just the number 1. then so let's review. We found a mine. We've gotten a list of its neighbors. We've checked its neighbors. If it's blank, we set it to 1. If the neighbor's already a number, so it's been marked by a previous mine, we get the value, increment it, and then save it as a string. And honestly, that might actually be it. No, do we gotta go one deeper? No, I think this might be it. It might not work, but I think we're ready to test it. We have a lot of errors. Super. That's how you learn shit. Okay, let's make our bash console bigger so we can see what's going on here. Did that work? There we go. That's better. Okay, so we have 4 column in range length row, object of type int has no len. There we go. I love it when they're easy. And by easy, I just mean me being foolish. Then let's make you bigger. My setup is getting a little messier, but that's okay. So, our rows are indices. As I said, being a good idea. That means that this row is an index. So we can't do length of row. We have to do length of start board row, because row is for each thing. Then for each of those rows, we want the number of columns. So that should solve a significant number of problems. Next error. Tuple object is not callable. We have row equal 0.0. God, I love making stupid errors on camera. Fills me with joy. I put these in parentheses. They need to be square brackets. And we're just going to do a quick skim down to see if there's anything else along those lines. Real quick. I'm not seeing it. Doesn't mean it's not there. Number 3. Ooh. We have less errors. String object does not support item assignment. Interesting. And is this the same error that we're getting this error for all of them? Yes. I see what's happening. A fault in my logic. Let's look at our input again. Our input is a list of strings. I was treating it as a list of lists because that's how I've implemented Minesweeper in the past. I define the grid as a list of lists, and thus each cell is its own point. This is a list of strings, and I did not take that into account. So we need to rethink our approach here. Can't make assumptions, not when programming. So here's what I'm thinking. We want to convert what we have into a list of lists, process it, and then output it in the way they want. Because I believe that way we're processing it is a very sound way of doing it. And that sane people would have stored this as a list of lists to begin with, but I digress. So step 1 is going to be transform our list of strings into a list of lists. Thankfully, this is pretty damn easy. Now, I'm going to do a fancy technique. Well, not fancy. Correction. If you're new to programming, this is fancy. If you're not new to programming, and especially if you're not new to Python, this is not fancy. I'm going to do a list comprehension, and I'm going to pray I do it correctly. So new board is going to be a list. It's going to be a list of we're going to take each row and turn it into a list, which will give us the characters. So what this is saying is, for row in start board, we're going to take the list of that row and put it in a new list. Now let's do a quick test in our in Bash to make sure this works. A simpler case. So we have a list. It's not a very good board, but it's a board. Let's do our comprehension. List row for row in board. And as you can see, we have a list of lists rather than a list of strings. This will be much easier for us to work with. List comprehensions in Python are very, very, very useful ways of quickly and cleanly making lists without lots of for loops everywhere. So, wherever we put start board before, we're going to replace it with new board. Now we want to go back to a list of strings. So let's do another list comprehension. We're going to join each of the individual lists together to form a string. The way you do that in Python is you say, here's our separator. We're going to join everything in the row and connect them with that separator. And again, let's check to make sure. Oh, I didn't show you what I just typed. So we had our comprehension. We replaced start board with new board in our code. And now we're doing a new comprehension that's going to give us back the list of strings. And now let's make sure it worked. So here's what we had before. And let's see if this worked. And voila, we've gotten back our list of strings. So one last look over. And let's rerun those tests. 3 failures this time. Assert raises, and I'm assuming the next one, value error not raised. Oh, what's this? Remember how I said with Exorcism you have to develop to the tests? I did not look at the tests clearly enough. So let's check them out. Looking for one that says assert raises. So this says test different length self. So if we get rows of different lengths, that's an invalid Minesweeper board, it wants us to raise a value error. That seems reasonable. Faulty border. Huh. This is going to be really, really, really freaking annoying to test. And invalid character. Also, not too bad to test. Okay, so. Oh boy, I was not expecting this. Okay, well, this is going to be fun. So, first up, let's do the making sure all of the rows are the same length test. The best way to do that, I think, is let's just do a validation step to start with. So, we're going to get the length of the first row. Now we're going to make sure all of the other rows are the same length. We're going to name it test row, just so that we're not using the same variable quite as often. It's generally a good practice to have, which I have not been super following in this, but we'll live. So, we're going to test each row. If the length isn't the same as the length on the first row, raise a value error. So that should cover that. Next, we want to check for invalid characters. I'm skipping the middle one for now. Validate character. So if it's not a star, it's not a dash, it's not a plus, now that I'm thinking about it, there's a better way to do this. I believe we can do this step and the checking the border step at once. So, what are the qualifications for a border? corners, it have to be pluses. Sides must be pipes. There we go. Tops must be dashes. And the insides must be blank, numbers, or mines. Cool. So, what's the condition for being a corner? Let's start with looking at the first row. The first row has to be corners. On the first one has to be a corner. Last one has to be a corner. The rest have to be dashes. So, if the column is 0, and the character is not a plus, the column is equal to the last index, so that's going to be the length of the row minus 1. So if the last character in the row is not plus, so if we're in the first row and we're not a corner, and we're not a dash, so we've covered the first row. The last row has the same set of rules, so we're going to check that as well. Remember, new board is a list of lists. So the length of the board is the number of rows. The final index is the length of the number of rows minus 1. So that's got that covered. Next, let's check the sides. Now, in this case, we've already covered the 4 corners above. Row is 0, col is 0 is 1 corner, row is 0, col is the final column, covers the upper right, last row, first column, last row, last column. So we don't need to cover the corners again. So if we're in those columns, if we're in a column, raise a value error. Last but not least, we're going to make sure the character is valid for our mine. Now, by doing for this, I'm going to say if it's not in this this list of valid characters. Again, this could be a formal set. I'm just going to do it as a list. So spaces are valid. Mines are valid. Now we're having space instead of 0. So we're not going to have 0, but we're going to have 1. There are definitely nicer ways to do this, but there's a reason I'm doing this. I'm stopping at 8 because you can't have something with 9 mines around it because there's only 8 possible neighbors. So if we ever got 9, this is a way to indicate that something's wrong. So this should validate our borders and incorrect characters. Hold on to your butts. Fuck. Well, that's not good. We just added ourselves an error. So, we have 12 tests, we're getting 9 errors, which means that we're always throwing an error for some reason, which is not ideal. Really hope that was going to work because I want to go to bed and do other things, like sleep. Okay. Looking this over again, we're not seeing where our error is being thrown. So, I believe the correct syntax for giving a message to a Python error is this. Let's, for now, raise a value error with the message of our character. There's probably something very simple that I'm messing up here, and many of you probably already saw it, but humor me, because I am slow sometimes, and it is quite late. Well, that was stupid of me. That was an incredibly unhelpful value error. Okay, let's smarten up. Right now we're going to make a formatted string. So, %D means we're going to fill the spot in with a number. %S means we're going to fill the spot in with a character or string. And this little tuple is saying here's what we're going to put into each of those spots that we said we were going to. So in spot 1, we're putting the row. Spot 2, we're putting the column. Spot 3, we're putting the character. So this should tell us everything we need to know. Figure out what I'm doing wrong. Okay, position 0, 0, character plus. That sounds like it should be right. Okay. Well, let's add some more clarity. We're now going to figure out which test it's throwing at. My coding is getting sloppier and I am starting to feel very foolish, but that is the nature of this experiment. You are not here to see me code perfectly, you are here to see me code. Okay, we're getting errors on our third test, and it looks consistent. Our third test is checking the first row and the last row. It's in the character should be a dash if it's not the first column or the last column. I see what I'm doing here. I'm checking two conditions at once. What I want to check is the column. Only do the check for plus if the column is 0. Only do the check for plus if the column is 0. And now only do the check for this if the column is not one of those two. So I was confusing my conditions. Trying to do too much in one step, very dangerous. And voila, our problem was solved. I do like that we're reporting what the value error was. So let's make it a little clearer. Hey, look, we've even improved our error handling. And we're going to make sure that I didn't fuck anything new up. Great. So, there we go. At least the first one went smoothly. But you know what? The second one wasn't bad. We learned what not to do while error testing. And we learned to read the specs of what you're supposed to be working on, which is a skill that you can never learn too much. Anyway, I hope this was remotely interesting. Please let me know. If this was, I know this isn't, the most exciting thing I've ever done, but I really would appreciate if you're an experienced programmer, if you're a new programmer, just if watching someone work through exercises is at all helpful. Because I think there's some potential value here, but I could be talking out my ass. Anyway, enough rambling. Video's gone on far too long, but please let me know what you guys think, what you peeps think, and until next time, Doublebyte out.